What does SEER mean? Um, SEER is a term being used to identify an air conditioner efficiency. The term SEER itself stands for Seasonal Energy Efficiency Rate. So here in this video, we're trying to kind of explain you guys, or even like people out there, homeowners, what does it mean by having, let's say, a 13 SEER air conditioner versus having a 16 SEER one? What are the differences? On this video, we're trying to explain that to you guys, but before we go ahead and explain that, we're gonna show you guys kind of a brief explanation of how a central air conditioning system works. So I've prepared this slide, the next slide that you will see here, to have a brief explanation of the operation of these central AC systems, which will expand to all type of refrigeration system that we have out there in the market. That's the basic and the basis of how an air conditioning system works in all type of them. So here in this video, this green kind of square shape that you'll see here, that's your condenser coil or the outer unit. This triangle here is your evaporator coil or the A coil that we're using here, which will be your indoor unit. And then this pipe, this line, technically being said, is your suction line or the bigger pipe that is coming from your coil to your condenser coil. And the orange one here is your liquid line. This one here is the filter dryer. Here is your metering device. As I said here, it's either TXV or piston for residential applications. This is your compressor, condenser fan, indoor blower, and yeah, that's all about it. So the way that the system works, we're gonna start from the compressor. Off the compressor, there will be high pressure, high temperature vapor refrigerant coming out. As refrigerant traveling through the coil, through the condenser coil, this condenser fan is kind of taking in the ambient air, kind of pulling it in inside the condenser, and as it passes through the condenser, it's gonna absorb a certain amount of heat from the refrigerant into the coil, and then reject it out through the top. Sorry, or for the side discharge ones, you'll see the condenser fan would be on the side of it instead of the top, but it's the same term. So as the refrigerant is traveling through the condenser coil and the condenser fan motor is working, condenser fan is working, is pulling in air from the ambient air, and as the ambient air is passing through the coil, it's kind of absorbing the heat from the refrigerant into the condenser coil and rejecting it out. Refrigerant gets cooler and cooler as it's traveling through the condenser coil. With saying cooler, it's not kind of really, you're not gonna really sense it. It's not gonna get cold, but it gets to a point that we call it a saturation point, where the refrigerant just starts to liquefy. That's where the condensation is happening, because the refrigerant is giving up its heat, and it gets cold to a point that turns from vapor into the liquid, but keeps the pressure and the temperature. So the high pressure, high temperature vapor refrigerant will turn into a high pressure, high temperature liquid refrigerant. And that happens in the saturation point, which is kind of in the middle of the condenser coil. It's supposed to happen there. And we call that point the saturation point, where both liquid and vapor exists. As refrigerant leaving the condenser, it should be fully liquid. So you will have a high pressure, high temperature liquid refrigerant traveling toward your evaporator coil. Passes through the filter dryer. The filter dryer here absorbs the moisture in the system, and some small debris or whatever. But yeah, the main reason of having a filter dryer in your system is to absorb the moisture from the system. Passes through the filter dryer, gets to your metering device before it enters the coil. So the metering device on residential air conditioners, it's either a TXV, which is a thermostatic expansion valve, or a fixed orifice or a fixed piston, what we call it. So what it does, it restricts the flow of the refrigerant to the coil. That restriction will lead to a pressure drop and subsequently a temperature drop. So your high pressure, high temperature liquid refrigerant will turn into a low pressure, low temperature, still liquid refrigerant. This liquid refrigerant, which is very low on pressure and again also low on temperature, according to the combination of Boyle's and Charles' law, which indicates as the pressure drops, the temperature drops as well. So this low pressure, low temperature liquid refrigerant travels through your evaporator coil and gets again to a point which we call it again saturation point, where the liquid refrigerant is just vaporizing. So in that point, both liquid and vapor exist. We call it the saturation point. From this point, the refrigerant is vaporizing because the indoor blower, which is coming from your air handler or a furnace or whatever you have, this blower fan, this blower motor is blowing the air that is coming through the return dock in your house or any type of other system that you have, but it's a return air. The return air is coming from the house back to your air handler to be blown to this the evaporator coil that you guys have here. So this air technically is the same temperature of the air that you have inside your house, which is going to be warmer than the temperature of the refrigerant in your evaporator coil. So as the air is passing through it, the heat always travels from the warmer object to the cooler one. So as the air is passing through your coil, it will kind of the right term to be used here, the refrigerant will absorb the heat of the air because the air is warmer than it. So it just tries to kind of equalize the temperature with the air that is being passed through it. So it will absorb the air, it will absorb the temperature from the air, gets warmer, and as it gets warmer, it vaporizes. And also the air that is being passed through the coil is gonna get colder because the refrigerant has absorbed the heat of it. So that's how the cool air comes to your house. And when the cool air comes to your house, again, the temperature of the air inside the house is warmer than the temperature of the air that is coming to the house. Then again, this cold air goes to the house and absorb the heat from the existing air in the house, and then come back to your air handler in the same cycle all over again. And that's technically how your house or your property is being cold. This vaporized refrigerant travels back to your system as a low pressure, low temperature vapor. So it enters the coil as a low pressure, low temperature liquid, leaves the coil as a low pressure, low temperature vapor. This vapor refrigerant goes back to your system through the suction line, which is the bigger line you find in the residential air conditioning system. You will always have a bigger copper tubing that is insulated, and that will be your suction line. That's the one that is bringing the refrigerant back to your compressor. It goes to the compressor, and the compressor will kind of compress that refrigerant, and by doing so, the refrigerant that's going to leave the compressor turns from the low pressure, low temperature vapor refrigerant to a high pressure, high temperature vapor. And the same cycle happens all over again. I will explain in another video what's the difference between a thermostatic expansion valve or a piston, but I will just give you a brief explanation of what is subcooling and superheating, which are very important factors to evaluate an air conditioning system. And technically, these two will tell you exactly what's happening in your air conditioning systems in terms of troubleshooting it. Because when you go for a service or a repair call on a Central AC, there are two scenarios. One of the scenarios is that your air conditioner is not even turning on, or one of the components is not working, which is going to be the easiest fix, because literally on the majority of the standard air conditioning system you only have 4 components. You will have the compressor, condenser fan motor, a capacitor, and a contactor, which are very easy to troubleshoot and replace. But when you go to a service call where the air conditioner is working, every single component, I mean the mechanical and the electrical component are working, but the system is not cooling down the house, or it's not cooling down the house properly, that's going to be your hardest service call. Always keep that in mind. That's when the refrigeration knowledge comes in play. So for that, you have to be familiar with subcooling, superheating. What are they? So as I said here, subcooling is subcooled liquid refrigerant is at a temperature below or colder than the temperature at which the refrigerant would evaporate. And I tell you, what does it mean? Superheating is the phenomenon in which a liquid is heated to a temperature higher than its boiling point without boiling. Very important. I don't want to get into really into depth of what's the latent heat, what's the sensible heat. I can explain you in a different video and go more into details with them. But you have to know subcooling happens in the condenser, superheat happens in your evaporator, and when you have a thermostatic expansion valve, you always want to measure the subcooling and charge your system and evaluate kind of your system with measuring your subcooling. And when you have a piston or fixed orifice metering device, you want to go and kind of examine and measure the superheat. And these two numbers tells you literally everything that's happening in your system. Very important, very, very important. Just give you an example here. Having a higher superheat simply means that your saturation point is going to be very close to the entrance of this coil, or technically very close to your metering device, like right after the metering device, when you have a high superheat. That simply means that you either have a restriction in your system. It can be on the filter dryer, it can be on your metering device, or there is no enough refrigerant in your system. That's why there is not enough refrigerant going through your coil, and it's just vaporizing pretty quickly at the beginning of the coil instead of doing it at the middle of the coil. That's when you will have the high superheat, because the superheat is the temperature difference between the saturation point and the temperature of refrigerant that is leaving the coil. That will be your superheat. So the temperature difference at your saturation point and the refrigerant that is leaving the coil from here to here. This is the temperature that your gauge shows, and that's the temperature you have to read with a thermometer. That will be your superheat, but we mostly measure the total superheat, which will be the temperature difference between the saturation point and the temperature of the refrigerant that is entering your condenser coil before it gets to the compressor. That will be the total superheat. And subcooling, the same, the temperature difference between the liquid refrigerant that is leaving the condenser coil and the saturation point in the condenser coil, which this temperature again is the temperature you will read on your gauge, the red gauge or the high side, and this is the one that you have to measure with the thermometer. Another reason for having a higher superheat, which is very important, guys, and I've seen a lot of installers out there, they don't do this, is the airflow. Let's say if you have a 2-ton air conditioner and your airflow is set for a 3-ton, you will have almost 400 CFM of air, like excess air that is passing through the coil, which is gonna make this refrigerant to vaporize much faster and quicker than when it's supposed to. So it's really important when you install an air conditioner. If you haven't installed that furnace or the air handler yourself, it's an existing one, just go there, make sure that the airflow setting is right for your new air conditioner. If you have a 2.5 ton or 2-ton, usually it's 350 to 400 CFM per ton. So you have a 2-ton or 2.5 ton. For 2-ton, you will need to have an 800 CFM at 0.5 inches water column static pressure, and for 2.5 ton, it's 1,000 CFM and so forth. So you always have to adjust that airflow. Different furnaces, different air handlers have different settings. And some of the models, Carrier, Goodman, the GMVC ones are 1590 P6. They have dip switches on Lennox different, Train different. So you have to go through the manual. If you do a bunch of them, you will learn pretty quickly. So yeah, always make sure your airflow is set properly. Try. I know it's hard. I know it's time consuming, guys. But if you have the right tools, it's just gonna take you a few minutes. Try to measure the static pressure after the filter and before the coil. The difference should be 0.5 inches water column. Within that range, 0.4, 0.5, 0.6 approximately. That's what you want to have after the filter and before the coil. You will need to have 0.1 inches water column static pressure across the filter. Always measure this. If you have a higher static pressure, you will need to adjust this airflow slightly more than what is supposed to be to overcome that static pressure in some cases. So it's very important. Yeah, and so many different scenarios. Having a very low superheat simply means that your saturation point is very close to toward the end of the coil, where the refrigerant is exiting the coil, and having literally zero superheat simply means that liquid refrigerant is going back to your compressor, which will lead to a burnout, or it will cause problem damage to the compressor. So don't want that. That can be caused by the bad TXV that got stuck open. A lot of refrigerant is going to your system, or a bad TXV. What's that called? The that probe that you kind of hang on your suction line to measure the temperature of it. But anyways, yeah, sorry, the TXV bulb. Yeah, that was the term for it. So yeah, very important. I try to make another video to explain more these subcooling and superheating in depth. So we technically know, just a quick recap. Off the compressor, we have a high pressure, high temperature vapor refrigerant inside the condenser coil. As it passes through the condenser coil and the condenser fan is working, it turns from the high pressure, high temperature vapor to a high pressure, high temperature liquid refrigerant, passes through the filler dryer, passes through the metering device, drops in the pressure and subsequently temperature. So it turns from the high pressure, high temperature liquid to a low pressure, low temperature liquid. And as it passes, as it's traveling through the evaporator coil, as the inner blower is blowing the air to the coil, it turns from liquid to vapor, but it's still low pressure, low temperature. And this low pressure, low temperature vapor refrigerant goes back to a compressor in the same cycle all over again. So now, what does a higher SEER AC mean? What does it mean by having a higher SEER air conditioner? Is it any better? Should we do it? Should we not do it? Well, the answer to that question is very hard, because it really depends what you really want out of your air conditioner. Because there's some people, they're really looking for something really fancy, something that looks nice, something that is quieter, and so forth. But technically, the only difference between having a higher SEER air conditioner versus a lower SEER is just the power consumption. So here I give you an example, but here I've written here, it says a 13 SEER AC, for instance, means that the AC produces 13 BTU of cooling per 1 watt of power usage per hour. So when you have a 13 SEER, simply means it produces a 13 BTU of cooling, just 13 BTU, not 13,000 BTU, 13 BTU of cooling per 1 watt of power usage. So if you have a 16 SEER, then it will produce 16 BTU of cooling using the same amount of power. So there are 3 SEERs difference here. Example, we have a 3-ton 13 SEER AC. It consumes 2.77 kilowatt power in 1 hour to operate. So that's how it's been calculated. 3-ton air conditioner is 36,000 BTU. Each ton equals to 12,000 BTU. So you have a 3-ton, it means it's 36,000 BTU divided by 13 BTU of cooling that it produces per 1 watt of power usage per hour, divided by 1,000 or times 0.001, it gives you the kilowatt. So a 13 SEER air conditioner consumes 2.77 kilowatt in an hour, and a 16 SEER with the same calculation you will have 2.25. Considering an AC works 8 hours a day and 4.5 months a year, the results will be as below. A 3-ton 13 SEER AC consumes 2,991.6 kilowatt power in a year to operate. So this was in an hour, turning it into a year by kind of assuming that the air conditioner works 8 hours a day and 4.5 months during the year. So in the entire year, the 3-ton 13 SEER uses 2,991.6 kilowatt, and the 16 SEER uses 2,430 kilowatt. The average utility cost per kilowatt is about 15 cents, here at least in Toronto. So by putting this into account, the cost of operation for a 3-ton 13 SEER AC is the kilowatts that it uses per year times 15 cents per kilowatt. And I put it 0.15 because I wanted to change it to dollar amount. So 2,991.6 kilowatt power that the 13 SEER air conditioner used during a year times 15 cents will give you $448.74 in a year. And then the cost of operation for a 3-ton 16 SEER with the same calculation gives you $364.5. So your saving per year with having a 16 SEER versus 13 SEER is about $84. So if you have a 16 SEER air conditioner versus having 13 SEER, you approximately save $80. So this $80, it can be 60, 50, or it can be 90, 100, but $80 with our calculation. So $80 in 10 years, you will save $140. Does it worth it? To me, no, it does not. I only recommend to have a higher SEER air conditioner for brand new homes, when they can put a modulating variable speed air handler or a furnace with a two-stage, not even 16 SEER, like 20, 21, or some 26 SEERs the carrier has. That worth it. That unit worth it. If you have everything kind of high end, that's worth it. But if you have an older furnace or an air handler in an existing home, you want to have a higher SEER air conditioner, no, I highly don't recommend that. Doesn't worth it. This $800 is approximately the price difference between a 16 SEER versus having a 13 SEER. 800, 500, 400, depends on. We have all type of guys out there, you know. They're guys. I think in the early future there will be guys that they install an air conditioner and they also pay something to the homeowner. You know, let me pay you $1,000 to install your air conditioner. Anyways, yeah. So I hope this video helped you guys out there to kind of explain to your customers how what does a SEER mean, and even for homeowners to understand what they're purchasing. But yeah, if you have any questions, just put in the comments below. Thank you.